Before we start our third session of the day, this is our speaker, Pankaj Tiwari, and he's going to talk about how Druid powers real-time analytics at British Telecom. So just as a little introduction, Pankaj joined British Telecom in 2012 when it was just building up its presence in India. His journey at BT has been a really learning experience, which has touched from activation to inventory management to monitoring and reporting. He is now the head of engineering. So take it away, Pankaj.
Thank you. Thank you so much, Rachel, for the introduction and this opportunity to be able to tell my story, which hopefully can help more teams across the globe who are either going to or in the same place as ours in this, time series journey. Actually, I just realized it sounds pretty fancy, time series journey. I'll just move on. If not all of you, most of you will know what is BT. We have a great and a long legacy. And what we are really proud of is our commitment to ensure that we provide connectivity to everyone in the UK. We are big, but we love to pivot and keep experimenting. Today, we are not just a broadband company. We were at the heart of London 2012 Olympics and Paralympic Games. And then you all know that we launched BT Sports in 2013. In 2016, we went on and bought EE, which is now a proud member of our family. We have been first to launch 5G in the UK, and now we have launched it across 50 cities across all of the UK. A proud moment for all of us in BT. We did all that, but it's even more important that we ensure that all of what we do keeps working, no matter what, every second, and possibly forever. And this is where I come in. My role is to underpin the software that helps run the network at BT at its best performance. You see NPR here, that is Network Performance Monitoring and Reporting Platform. And in this, we use a bouquet of tools and technologies to monitor performance for all of our BT network, including RAN and core for EE. And again, if I'm talking about EE, we are not just monitoring 5G, but because, as I said, we have a long legacy, we go back and monitor 2G as well if our customers need it. The technology that we choose should be able to cater to the demands of being 100% available, being real-time, self-monitoring, remediation, and customer-centric. Whatever you see here, these are not just buzzwords, but a mandate, because when we are able to do a tick mark for that, we enable and ensure what really, really matters to our customers. A great reach to help people connect to each other anytime they want with committed guarantees. And thus the final goal of giving an amazing and awesome customer experience. We, as I said, we are pretty big, and the NPR monitors around 94 billion data points per day, just to give you an idea of the volumes we are managing here. In one of the key deployments within BT, in one of our network stack, 21 converged network, we have more than 40,000 network devices. We process around 4 billion collections per day across 7 million managed objects. Now, with the sheer volume of the numbers that I just throw at you, the need for us to always be up and always keep polling. We have to keep disrupting our ways of working. We have to find and then optimize our technical stack almost continuously. As we're collecting metrics every minute or even sub-minute via SNMP, telemetry, bulk feed, etc., we knew we had time series data at our hands. And thus, we wanted to move away from the traditional persistent stores, I'll not name anything here, to something which has native support for that particular data format. And when we started with three-way comparison. We started with Prometheus, Cassandra, and Druid. However, Cassandra was being used in BT already. So eventually, we narrowed down to just these two, basically Druid and Cassandra. And then we did a use case based comparison across ingestion, scalability, read performance, aggregation, high availability, and one of the very important factors for us was the community support for that particular technology that we choose. Now, both Cassandra and Druid do a fine job for different use cases. But for us, in our specific BT environment, things which turned out to be the decision makers were being able to support streaming data. The Nokias and the Ciscos of the world are moving towards telemetry, and we wanted to be able to poll them. We wanted to be able to have something which supports roll-up during ingestion itself and has a native support for aggregations. That's when we decided to work with Druid. Now, one of the decisions was taken to go along with Druid based on our POC. We decided to roll it out in our production stack. You know the difference between POC environment and a production environment, right? And here is when we realize that no matter how beautiful your POC numbers are, before going to production, you do need to take a pause and ask yourself, do you need some expert help at that point, or you need to have a future roadmap of bringing in some expert if there is a need? You need to have a risk mitigation plan there. What we initially thought that we will be fine, we have a bunch of brilliant engineers. But what we did not factor in was the bandwidth of our engineers. When we started, our engineers were very excited. It was a new technology, ready for adoption. And initially the developer excitement on whole floor was really great. But we have to understand that in Druid, there are several moving parts. And our engineers were being pulled into two different directions simultaneously. One, to meet the business demand, which itself requires engineering. And second, obviously, to ensure that all of the Druid's parts were working in the best possible way. Not easy. And our developers started feeling that frustration. We needed a partnership. And that's when we decided to bring in experts. And we partnered with Imply in Q2 last year. So you can call it a novice or a newbie in this journey with Imply. And that's why possibly I may have a lot of things to share, which can help you in your journey as well. Since our partnership with Imply, fingers crossed, we have just been able to replicate Druid's success as you read about on internet, on books, in BT environment as well. And then I should explicitly say here, the success was in production environment, because POCs have a tendency to always work out awesome, right? I'll just move on. And this is a little bit detailed slide where I just wanted to ensure that you get a view of our architecture as well on a high level. Now, once we decided with Druid and once we partnered up with Imply, our job with introduction of Druid was very simple. Provide real-time monitoring and real-time analytics and never go down. We started with open source as I told earlier, and then eventually moved to Imply. And we have been working on version 3.0 and 3.2 both. Now, if you see the architecture diagram on the right side, you'll see that we have pollers, which basically poll SNMP data, telemetry data, any kind of data actually, and they are pluggable modules into our stack. And they have been written in several technology, which basically feed all those different kind of data, normalize it, and put us into the Kafka layer. Now, the poller's job is again very simple: to never die and never miss a single data point. Now, the data from Kafka is then siphoned off to other components who wants to have a stream of the poll data that we have created. From there, we do a parallel feed into our two active Druid stacks across two different data centers. Now, remember, we had started with an open source version of Druid. So when we started, we had to build our in-house Druid monitoring engine. We built it using Grafana, which most of you can recognize with this font on the left side. Now, after our partnership with Imply, however, we have been using Clarity for all of our Druid stack, and life has become easier with Clarity, not just for developer, but for the operation team as well. We have MySQL metadata cluster across data centers now, and this is very important for us. So I'll take a small moment to explain a little bit more. because it helps us in knowing ingestion status related to segments, task status. And all of this is very important across both of my data center, because for me, the Druid instances, that is the real truth. What metadata clusters tell them. The Druid layer then fits the data into 3 different platforms. The data platform is basically a machine learning and analytics platform that we wanted to leverage upon the Druid, and it is our gateway into cloud as well. It also feeds to a BI layer. For BI, I know Imply has Pivot, which is again great, but we already had a strategic BI tool in BT, ClickSense. And what we did is, because in Druid, we are storing a lot of metrics, we do not use their name as such, but we are using metric ID. And hence we had to do this small mapping of converting this metric ID into something which made sense at BI layer, right? So what we did is we put a layer of Hive, and this layer of Hive basically creates a view on the Druid persistence, so that what would happen eventually is, once you have the views on Hive, which will do those conversions and then allow users to play with those names, they can get insights from all of the data which Druid has to offer. I'll move on. As I said, right, we started with open source version, and I have to say the documentation for it was not really up to the standards. It really can, go a long way. And with our engineers' help, as you already know, with difficulty, but we did manage to put everything in production in a working condition. But our configurations were not up to the mark. Configurations were screwed up. For us, it was like we were flying, a rocket, but expecting the gravitational pulls to do all the work without any fuel on board. It was not the ideal state to be in, considering the brand and considering the value that I committed in the starting of my slide deck to our customers. I'll just give certain examples, and I'll also follow on with those examples of where Imply was able to help. Now, segments, for example, we only were thinking about segment sizes at the time. And we realized after our partnership with Imply that it was a wrong lens to look at segments in our BT context. We had segments with around 40 million records. And obviously, if you have such huge segments, no matter how much RAM you give it, it will never be enough. It will keep on crashing. Now, Imply, after the partnership, suggested that we should not look at that lens. We should not work with segment sizes, but we should work on the currency of maximum records stored per segment. Now in BT, again, every environment in every company is gonna be unique, and you have to adapt everything according to your particular needs, right? And you will learn it on the way. What we did is in our BT environment, because possibly it being telecom, we realized that our dimensions, which you will know if you are from telecom background, such as device name, sub-element name, port name, etc., they have corresponding thousands of metrics. Because what happens is, as we go up in the aggregation chain, we keep on adding more KPIs, min, max, sum, median, average, and then those formulas that you will have A plus B divided by 2, because the user that are consuming this data need that data in a particular format. They have their own commitment with their particular resellers. So what happens is, for certain dimensions, metrics goes up in thousands. And suggestion for Imply was to limit the segments to around 4 to 5 million records. And that really, really helped us in just satisfying the compute needs for the Druid cluster. Now in BT, we have our own data centers. And thus, rather than asking several commodity machines, it is easy for us internally to request for a big BP machine. And we thought initially again that using BP machines will satisfy all the requirements of our middle managers. But again, with Imply, we realized that that is not the right way to go. We had to distribute, say, middle managers across different machines, and then configure the right slots on each middle manager to make it work optimally. Another example around ingestion, before I move to aggregation, will be, when we started, our ingestion was allocated randomly to various middle managers. Now, what happens because of this is you create a choke point. There is no affinity at all here. And there is no categorization of high priority tasks. There is no way for Druid to understand what are the tasks that has to pass through if there is a memory crunch, if there is a compute crunch, if there is a storage crunch. And that is where Imply again helped us, because then we were able to prioritize and affiliate a particular high priority task to certain middle manager, which had that higher compute that it needed to kind of do justice to that high priority task. We had aggregation issues in starting because our slots were misconfigured. And we had to then learn to configure more slots for those JVM tasks in middle managers to ensure that the internal jobs, which even though have lower priority, does keep working, because you need to keep the cluster healthy in the first place before you go about and try to do the world changing things. You will not believe, but when we started, our cache was disabled. And then when we enabled it, we gave it very little memory. Obviously, because the memory was less, every time the persistence layer was getting hit. And obviously, we did not know that. What is the right memory to give it to cache? Because we did not have eyes there. We did not have a clarity tool, which Imply brings in. Now with clarity, what happens is we realize a very clear distinction that the hit ratio on caches was very less. And then cache size, etc. It really helped us to fine tune our cache size. Another very simple example, which I will give, was, we had 64 cores, but we were using around 40 because we did not want to break something else that was unknown to us. And with Imply partnership, again, right, it helped us, right, because we increased that to get more from the CPU as well. We, in fact, configured our brokers to parallelly connect to multiple historical by parallelizing the query. So again, your queries are getting faster. We learned about a scan. We were fighting our battles with selects. And once we came to know that there is a better optimized grip by and there is a way to select via scans, it just made our life easier. It made our queries go 10 times faster than when we started. We have not used tiring yet, and I have heard about it. Basically in BT till now, we have been using tiring to create replicas, as in, you have two tiers, tier 1 and 2, and they will be just replicas of the data sets. But I think this is where we possibly will spend our next quarter in trying to do this hot and cold goodness of cluster tiring. I'll move on. And this is my final slide, where I just wanted to talk possibly what we could have done different if we had a chance to go back and change a few things. So from BT perspective, as I said earlier, we did look at several facets before deciding on Druid. But even though the community support was there on GitHubs, etc., we did not get a lot of documentation for the open source version. And my recommendation to you guys is not about just Druid or any time series database, any technology per se. It is very, very important to seek out the real right documentations. The second thing, as you must have guessed from my talk till now, is that we were not sure whether we should partner with somebody who is expert on Druid sooner or later. And my advice to you, and when I'm looking back, is to be able to bring in the experts sooner. Decide fast that what are your priorities. If you want to make changes in the source code of something and that is your business, that's fine. But if you want to do something else and your business core values lie somewhere else, bring in the experts sooner. From Imply perspective, I think the context of telecom is very important. And when we did this partnership, and I have seen a lot of product companies we bring along in BT landscape, sometimes the company needs to add that extra dimension to the product companies for whatever they are doing today. For us, that missing piece, that nice context to overwrap all the goodness under technology was the telecom. And we also now look back and see that possibly, I mean, it's not possible, but in the cloud world, there is a chance where there can be a tiny customized particular client environment. What happens is, if you know what client environment looks like, from a product company perspective, it becomes easier to solve the problem in production. Now, together, now BT and Imply, I think what we have to do is we have to continue on this journey with Druid, with Imply. Now with Druid itself, we enhance our speed to almost 3-folds when we started from traditional persistence stores. And with Imply, now we are running at least 10 times faster than when we started. Continuous value add with faster delivery, right? And obviously, because we are clients, in a cost efficient way is what we have to build in this partnership together. And I think we strive to challenge ourselves even more as we go forward. I think, in my opinion, in this time series world, we have just scratched the surface. And I think before we open up for question, because this was my last slide, for the folks in the call, I really, really hope that my learnings help you guys. And even after this talk is over, as Rachel pointed out in the beginning, feel free to connect with me on LinkedIn if you have any queries whatsoever along the way of your Druid adoption. Thank you.
Fantastic. Thank you so much for that, Pankaj. We've got lots of questions for you. So get ready. One thing that I'm actually very personally interested in, what were the main reasons to discard Prometheus initially and go with a Druid and Cassandra?
So as I said, Cassandra was already being used in our environment, in our BT environment. And there was a lot of push at the time to start using Cassandra as it is from day zero. Okay, so what happened is when we started looking in Prometheus, there was nothing wrong in Prometheus, but the things that we are looking for, as in the roll-ups, the native aggregation support, and to be able to be highly available across data center. So these are the 3-4 metrics which actually pushed us towards eventually going towards Druid. Rachel.
Fantastic. Do you take in streaming telemetry, NetFlow, syslog, and SMP data?
We do, yes.
And can you share any learnings on running aggregations during runtime versus adding new metrics for your aggregations during runtime through transform specs?
Right. So the moment you can, the things is the lesser point of interactions, the better the streaming is, right? And if you want to do a lot of compute intensive work during the streaming process itself, you need to be very, very clear on what your compute is going to be. So if the technology does not support anything natively, you are adding a customized layer on top of it during ingestion. And as I said, my pollers live and die to collect everything that they can from the network at every second possible. So we did not want it to add a lot of coupling, a lot of layers on the streaming. So what we recommend and what we have seen from our experience, it's very, very good if the technology natively supports these aggregation rather than trying to do it at a customized level during your ingestion period, because you're slowing down the entire pipeline because you're choking it at the very beginning of it.
Fantastic. Can you walk us through some examples of a middle manager slot tuning and the benefits achieved through it?
Right. So the thing is, we had to, when we started, we had around 25 JVM tasks assigned for middle manager. I'm talking about my POC days. So there were 25 slots on each of my middle managers. And we did not know at that time, okay, we did not know that we don't have to necessarily give lot of XMS and XMX memories to JVM task to make it work properly, but rather have these slots optimized to be able to do a lot of different jobs across a lot of different commodity servers. Richard.
Fantastic. So what do you do to create different time roll-ups, daily, monthly, yearly data on the same raw data?
Yeah, so what we do is we do raw data is then goes into daily and then hourly, hourly, daily and weekly, etc. What we do is we actually roll them up and we put them in a different column within Druid. So because it is natively supported, what we can do is we can actually keep on, as I said, right, we have a few dimensions. but we have a lot of metrics because of this. As we go up in this aggregation chain, we keep on adding. So all of this daily aggregations, and then formulas on those daily aggregated data, and then KPIs, which I said can be a custom formulas across different variables. Column A, column B gets added and then divided by, let's say, column C. So that is a KPI is what I refer to. All of these get added and appended in a different metric. So they again become one more metric. So that's why we go to till thousands of metrics, because every layer then at least adds on to four new metrics, min, max, average, sum, etc. So we keep on adding to it, keep on appending to the matrices, because whatever the BI tool needs, whatever our user needs to find that insight to help business, we enable that.
So we got a lot of people asking you about the costs of Druid and the size of the clusters, and what can you tell us about the size of the cluster, how you're keeping costs down? Tell us about that type of information.
So we have, when you say, Rachel, when you say in terms of keeping the cost down, you mean in terms of compute or storage, etc., right?
Yeah, saying please talk about the cost of Druid to take into production with a given configuration. And I just took it a step further, knowing that people are always interested in what types, how are people managing their clusters in terms of costs and size?
Right. So look, the thing is, we do have a lot of data coming in. So we do have to have several machines to be able to span middle managers. I will not be able to give you exact specific details of how many middle managers at this point, because I do have them scaled up and scaled down whenever there is a need. So if there is a Amazon is doing a broadcast, or there is a UK Prime Minister coming up and trying to talk something about COVID, we have everything in the entire tech stack scalable. Okay. And as I said, because it's geographically resilient, we have it in 2 different data centers. They both follow their own pattern in terms of getting scaled up and scaled down. Okay. And at middle managers level and at overlord, at broker level, at every level, we do that scaling up and scaling down using certain scripts. Okay. And we do have storage. If you ask me, we have terabytes of data, because as I said, we are actually pulling billion data points per day across thousands of network elements in BT. So the storage goes on terabyte, and along with housekeeping, etc., we live with that terabyte amount of data. But as we keep on rolling up, we try to get rid of raw data. So raw data has a maximum span of 3 quarters in three months in our BT state. After that, we kind of take it away, and we live with our aggregated data. I hope that answers some of the questions, Rachel.
Yeah, actually, one of the questions did come back is how was your data retention policy? So thank you for addressing that as well.
Because raw data is too much to manage and keep it forever because of the humongous data points that we collect. So we do it for 1 quarter, and then we get rid of raw data. We live with the aggregated ones, which basically the business needs.
So do you manually scale your middle managers up and down, or do you have an automated way of doing that?
No, we do have an automated way. We have created certain automated ways to be able to understand that there is more data now landing in the Kafka layer. So we need to be able to process it. And we have certain unused boxes, which then start spawning up middle managers. It's automated because we don't want to bother our ASGs every time there is a Fortnite deployment or there is a new game coming in.
We've got so many other questions here. We're going to probably have to follow these up with a blog post. We've got 26 that are open, so there's no way we're going to get to all of them. Do you have any last things that you want to say to people in terms of, you made lots of really good recommendations, but based on these questions, any other sort of final thoughts?
Yeah. So as I said earlier, look, it's important to try new things. It's important to keep on pivoting. even if you are as big and as large spread as BT. But you need to understand that what is the right time to pivot. Do not go too much deep into your trial and error method. Find a point where you need to pivot. And I'm not saying there need to be an early pivot or late pivot. It depends on what your organization capability is, but be ready to pivot and plan it as part of your risk mitigation when you go down this rollout journey.
Awesome. Thank you so much, Pankaj. This has been an absolutely fantastic presentation, and we will make sure that these slides and presentation and a follow-up blog post with these questions get sent out to everybody on the call. So thank you, everybody, for your participation. Talking about large data sets, our next session comes up in 28 minutes with analytics over terabytes of data at Twitter. So everybody go out, wash your hands, find a comfy spot, and we'll see you soon. If you have any other questions or you want to share your own stories, please feel free to reach out to us at community@imply.io or send us a note on Slack or in the Google groups. So thanks again, everybody.